Welcome guys, hope you're enjoying my videos, doing fine. As you can see here, I have yet another question, which is also a subjective question. So we start with an acute triangle ABC, and M is the midpoint of CA, the side CA. And AD is perpendicular to BC, with D belongs to BC. Basically, D lies on BC. So this tells us that D is the foot of the altitude from A. And now, as given here, in this line, you can see that the circumcircle of any triangle ABC is denoted by curly brackets ABC, or parentheses ABC. So here we have parenthesis MCD, where the circumcircle of MCD intersects AD at N and D. D is obviously one common point, but we're saying that the second intersection point is N. So AD meets the circumcircle of MCD again at N. And here we have DM intersection CN. That means DM intersects CN at X. And here we have triangle CXM. Here CXM is the triangle formed by C, M, and the intersection point X. And here DXN has a circumcircle, and these two circumcircles intersect at X, which is one obvious common point since X is there in both of these triangles, and Y is the second intersection point, which is what we're worried about right now. And then XY intersects BC at Z. So, well, of course you have to extend XY to meet BC at Z. And the circumcircle of, like I said earlier, this is how you denote the circumcircle. Now you have to prove that ANYC and AMYD are cyclic. This is the first part of the question. ANYC and AMYD are cyclic. I would say if this was out of 7 points, like an IMO question, I would say this part would be barely 2 points because it's like very easy compared to the second part. And if it was out of 17, like RMO or INMO, an Indian National Olympiad, then it would be probably 4 or 3 points out of 17. And this is the hard part. We have xy by yz is equal to AD squared by CA squared. If you simplify this, you will realize this is just sine square C, where C is just angle C, angle ACB. And here we have AB is perpendicular to GZ. So you have to first develop the expression for xy by yz, and then equate it to this, and then see what value of C or whatever angle you get out of that. And then here, you do the same thing but for B. We already know the angle C, so that makes it easier, or that makes you a step closer to finding what angle B could be, or angle A. And G is the center of ABC. Now we have to determine the angles of the triangle ABC. All three angles. So that's the question. And note that this results into forming my favorite type of triangle, which you can uncover by solving the question. Thanks for watching, subscribe for more such content, and press the notification icon for more such comment, and bye bye.